Have you ever wondered how a lemon or a potato can power a clock or an LED? It may sound unusual, but it's based on real science. In this video, I will explain how fruit batteries work using simple ideas from chemistry and physics, so the process is clear and easy to follow. A fruit battery is a simple chemical battery that uses two different metals and a fruit or vegetable. The fruit itself does not create electricity. Instead, it provides the environment needed for chemical reactions, and those reactions cause electrons to move, which produce electric current. Every fruit battery has four main parts: two different metals, usually zinc and copper, the fruit or vegetable acting as the electrolyte, and wires to connect the circuit. Each part plays an important role, and if any one of these is missing, the battery will not work. The fruit acts as an electrolyte, which means it contains a liquid with charged particles called ions. These ions allow charge to move throughout the fruit. Without this movement of ions, electrons could not flow through the circuit and the battery would not produce electrical energy. The chemical reactions take place at the electrodes. Zinc loses electrons in a process called oxidation. These electrons flow through the wire towards the copper electrode, where they are accepted in a process called reduction. This movement of electrons throughout the circuit is what produces electric current. For electricity to flow, the circuit must be complete. This means electrons need a full path from the zinc electrode to the copper electrode through the wire and back through the electrolyte inside the fruit. If the circuit is broken at any point, the flow of electrons will stop immediately. A single fruit battery produces a small voltage, usually less than 1 volt. This is not enough power for most devices. However, when multiple fruit batteries are connected in series, the voltages add together, allowing you to power small devices such as clocks or LEDs. A fruit battery works because of a chemical reaction between two different metals. The fruit acts as an electrolyte, allowing ions to move and complete the circuit. Electrons flow from the zinc to copper through the wire, producing electric current and a small but measurable voltage. Thank you for watching.